Hello, we are looking at chapter 7. So, this is about sampling distribution and central limit theorem. In this chapter, we are going to study what a sampling distribution is, and will study actually two types. One will be the sampling distribution for sample means, and the other one will be sampling distribution for sample proportions. A lot of what you did in chapter 6 you will find back in here in chapter 7, like finding the z-scores and looking for the area, the left, right, between, and out in the tails. So, but the z-score formula will change, and also for proportion we haven't done that before, so this will be something new. But eventually finding the z-scores and area, that is something that should be familiar. So in section 7.1 we introduced the sampling distribution. So that, and basically if you recall these means and proportion, what are these? These are, you can call them statistics. They are also parameters. Okay. So the definition is the sampling distribution of a statistic, such as sample mean or sample proportion, is the distribution of all values of the statistic when all possible samples of the same size n are taken from the same population. So, for example, if someone catches fish from a pond, so people are catching fish from pond. So if you restrict the number of fish, everyone is taking certain number, like 3 or 4, let's say. So one person 4, and you, when they take it out, you weigh them, each fish, and then find the average of the weight. So that is the mean of that sample. So then another person takes their 4 fishes to the counter, and they weigh, and then they say that the average weight of the fish is this much. So that is what we mean by sample means. So when we study these sampling distribution, we will see some review some words that we have seen in chapter 1. So let us review them here so that we are good when we get there. The first one is, what is population? Remember, it is the group of interest, the group about which we want to know something. Sample, a sample of measurement from the proportion, from the population, a subset of measurements from the population. Statistic, that is a numerical descriptive measure of a sample. So remember, statistic is a numerical descriptive measure of a sample, and parameter is a numerical descriptive measure of a population. Now it is important to note that for a given population, a specified parameter is a fixed quantity. Remember this, we have discussed before, that parameters are fixed because they are related to the population, but statistics may change from sample to sample. So some of the common statistics and corresponding parameters and symbols used for them are given in this table. So mean, so the parameter is mu. This is a symbol we use for the mean. And then for the, so the mu is for the mean, and the x bar is the for the statistic, the symbol for mean. Okay. Then we have proportion. So for population proportion, we use the letter p, little p, and for the sample proportion we use the p hat. If you notice, there is a hat on top of it. that's p hat, and the variance, the population variance is sigma square, and the sample variance is s square, and standard deviation is similarly sigma and s. So let's now define what a sampling distribution of the sample mean. So the same thing as the wordings are very similar to the definition above. So instead of the statistic, now we will say mean. So the sampling distribution of a sample mean is the distribution of all possible sample means or the distribution of a variable x bar with all samples having the same sample size and taken from the same population. So for example, consider a normal population with mean mu and the standard deviation sigma. And assume we repeatedly take samples of a given size and from this population and calculate the arithmetic mean x bar for each sample. Then this statistic is called the sample mean. The same thing as I explained a little while ago. So the distribution of these means or averages is called the sampling distribution of the sample mean. So instead of the given population, we want to focus on the values of the statistics such as sample mean or sample proportion. Let's look at a concrete example so that we can have a better understanding. So here is sample 1. A friend of mine has 3 children, ages 4, 5, and 9. So let us consider this the population. It consists of the numbers 4, 5, and 9. Now, in general, we don't usually take this smaller population because usually we don't know about, we don't have the data for the whole population usually, but in this case, and we don't take such small samples, but in this case, we are just going to, this example is good to understand what we mean by sampling distribution. So if, let's say, if 2 ages are randomly selected with replacement from the population 459, identify the sampling distribution of the sample means by creating a table representing the probability distribution of the sample mean. Basically, that's how we express or we display or identify the distribution by creating a table, probability distribution table. So how do we do that? Now think about it. If 2 ages are randomly selected with replacement from the population 459, how many different samples will there be? Because one could pick 4, 4, 4, 5, 4, 9, 5, 4, 5, 5, 5, 9, 9, 4, 9, 5, 9, 9, right? So which means we will have 9 different samples. You may select this blank by 9. So for some reason my pen, okay, there it is. Okay. Different samples. All 9 samples are equally likely, each with a probability of, so there are 9 of them, so the probability of each will be 1 over 9. So in table 1, we have listed all the outcomes, and in the first column and the second column, I have found the mean of each outcome. And then in the third column, I have written the probability of each of them. But now you see in the first column, there are some of the means that are repeated. So we will combine them and we get a concise table over here, the table 2. So we notice that the value 4.5 is coming twice, and 6.5 and then 7. These are repeated, so we write them once and then we put the probability in the second column. So this table 2 is our distribution level. So this is now notice that the population was so small, but we got like 9 different samples, and which can now we can say they have got reduced to 6, but still they are more than the sample. Now if you find the mean of the population, it is was 4, 5 and 9, so you add 4, 5, 9, divide by 3, we get 6. Now if we find the mean of the sample, so sampling distribution, so the mean of these values, then we again get a 6. Now this is not a coincidence. Actually, the mean of uh, the mean of this sampling distribution will be the same as the mean of the original population.